Hey guys, happy Friday. So today I am out, as you can see. I think I told every class on Wednesday, Thursday, but if you didn't know, I am out. I will be back on Monday. So today we're going to work on transformations of shapes and transformations of points. And what does this mean in math, okay? So the easiest transformation is called a translation, and that's what we're going to cover today. Okay, so let's zoom in. What is a transformation? A transformation is an operation that maps an original figure called a pre-image onto a new figure called the image. Okay, so the pre-image is a figure that's already given to you. It will be already there. It was drawn pre this time. What you're going to do is you're going to create a new image, and that's why it's called the image. You are creating the new image. On the graph to the left, triangle A, B, C is the pre-image, and triangle A prime, B prime, C prime. So those dashes look like one exponents. They're called primes, okay? Is the image. This is the one that's drawn second. So always the original letters is the pre-image, and every time you draw a dash, that's a move it makes. So we are going to make one move, okay? You can see this is the image, pre-image. This is the new image. It has A prime right here. It's kind of hard to see. Let me see if I can zoom in. On mine, I can zoom in. You can kind of see it better there. So here's the A prime, here's C prime, here's B prime. Okay. A transformation can change the position, orientation, or size of a figure. So what is a rigid motion then? Okay, a rigid motion is a transformation where the size and shape does not change, okay? So transformation where size or shape does not change. Okay, so like I said, there's gonna be, I think there's 4 totals. There's rotation, translations, dilations, and reflections. The only 3 of those are actually considered rigid motions, okay? So rigid ones are, again, the one we're doing today, translation, okay? Reflection, and last but not least, rotation. So we're going to spend a day on all 3 of those, a day each, and then a day on dilation when we get there. Okay? So now let's move on to the one I was talking about. We're going to talk about translations today. So what is a translation? Okay? It's a vertical and or horizontal slide of a figure. Okay? So a vertical or horizontal. Did I spell it right? I don't think I did. I guess it is. It doesn't look right to me, but it is. Horizontal slide of a figure. Okay. So the notation, I messed up. Okay, these are supposed to be switched. Okay, we'll write the notation right above it. Okay, what's going to happen is you're going to have your original point, x, y. Okay, that's the pre-image. That's where we're starting. Each point has its own pre-image location. When you transform it, when you slide it, you're either going to slide it on the x-axis with a plus or a minus, and you're going to do h, comma, and then you're going to move it on the y-axis up or down, and that's considered k. So h is the left and right, okay? That's called a horizontal shift, okay? So minus is left, plus is right. We're gonna have to go zoom out a little bit. Okay. So if you add to the x, you're gonna go to the right. That may, okay. If you subtract, you're gonna go to the left. Okay. K is the vertical. Okay, the vertical shift. So if you subtract on the y-axis, what's gonna happen? If you subtract, you're gonna go down, right? So minus means down. So what do you think plus means? If I add to my y point, I'm gonna go up, okay? Just like when you have your graph normally. So on the left of the x-axis is minuses, on the right there's pluses, on the bottom of the y there's minuses, on the top of the y there are plus signs. So on this one it gives us all of our vertices in our image. So we're going to draw out the image using Q, R, S, and T, and then we're going to shift it 5 on the x-axis and 7 on the y-axis. And both of those are plus, so this means 5 to the right, and this is plus, so it means 7 up. So let's do that first. So let's draw our pre-image. So Q, right here, this is where we're starting, is at -6, -1. So you start at the origin every time. 1, 2, 3, 4, 5, 6, down 1. Okay, and you're just going to draw the letter Q. The next is at -3, 1. So that means go to the 3 left. 1, 2, 3. +1 on the y means go up 1. And that's our original R. Okay, you can connect those if you want because we're creating a shape. It says we're creating a rectangle right here. Okay, the next one is at 1 on the x-axis and down 5 on the y-axis. So start at 0, go over to the 1 to the right, and down 1, 2, 3, 4, 5. Okay, and that is the letter S. Connect that to R. Lastly, T is at -2, -7. Okay, so -2, start at the origin, 1, 2, down 7. 1, 2, 3, 4, 5, 6, 7, right here. And it should make a nice rectangle. Boom. And that is our original, not Q, that's our original T. Okay, so these were our original points. Now again, to every point, we are going to add 5 to the x value and add 7 to the y value. So let's start with Q. So Q would be, here's Q's point, so -6, -1. Again, you add 5, so +5. And the y's, we're going to add 7. Okay, because it says add 5, add 7 to whatever your point is, whatever your x and y are. So where would Q be at? Q prime would be at -6 + 5 is -1. Okay. -1 + 7 is +6. So I'm going to use a whole different color for this one. I love this blue. Let's do this one. Okay, so at -1, that's start at the origin, go over 1, up 1, 2, 3, 4, 5, 6. Right there. And then you would write Q prime. Hopefully you can see that. I'll change the color next time. All right, so now let's do R. We have to do all of them. So R originally was at -3 and 1. And you have to do the same switch to all. So you're adding 5 to all the x's and adding 7 to all of the y's. See, it's the same as this one. Okay, so R prime is going to be at -3 + 5 is 2. 1 + 7 is 8. So R prime is going to be at 2, 8. So that means start at 0, go over 1, 2, up 8, 1, 2, 3, 4, 5, 6, 7, 8. And here is R prime. Connect them. Okay, next one. S prime is at 1 and -5. Oh, sorry, that's S regular, not X prime. That's the pre-image. So S was at -1 and -5 right there. So again, we're going to take these values, add 5 to find S prime, add 7 to find S prime's y value. So S prime is at 1 + 5 is 6, -5 + 7 is 2, So that's where S prime will be at. So starting at the origin, 1, 2, 3, 4, 5, 6, up 2, 1, 2. There is S prime. Okay. Last but not least, it's a rectangle, so we have T. Okay, T originally was at right here, -2, -7. Again, we're adding 5 and 7. 5 to the X, 7 to the Y. Let's see what these are at. Okay, so T prime is going to be located at -2 plus 5 is 3. -7 plus 7 is 0. So 3, 0. So that means go start at the origin, go 3 to the left, 1, 2, 3, and 0 up. So we just stop there. And there we go. And so now I've taken this whole rectangle, all the parts of it, and that's T prime. I've taken the whole thing and I have moved it up 7, over 5 to the right. Or you could say over to the right and then up 7. Okay, I did exactly what this told me to. Move 5 to the right, go up 7. Okay, if you guys want to do this, we're going to do this one. The next one is a triangle, CDE. Let's go back to purple because I feel like that was better. This one only has 3, so let's do them fast, okay? So, and this time it says take each vertex, C, D, and E, and what does this mean? This means go left 3. So -3 to X is going to the left 3, and then +8, is that going to go up or down? You should say that's going to go up because it's a plus. So the original C is at 2, -1, so start at the origin, 1, 2, -1 means go down 1. And there is our original C value, okay? The next point, D, is at 7, -4. So that means go right 7. So 1, 2, 3, 4, 5, 6, 7. And then go down -4. Oh, I lost my place. 1, 2, 3, 4, 5, 6, 7. Go down 1, 2, 3, 4. And that is our pre-image D. So no prime yet. And connect those. Our last point in our triangle, point E, is at 4, -6. So that's over 1, 2, 3, 4. Down 1, 2, 3, 4, 5, 6. And this is what your triangle should look like. And this was the original image E. Okay, so for each one, let's go a little bit faster this time. C prime would be at this point 2 -3, and then -1 right here plus 8. So where is that? Okay, so 2 minus 3 is -1. And then -1 plus 8, so 8 minus 1, if you want to do it the opposite way, would be at 7. So -1, start at the origin. -1 means go left 1, up 1, 2, 3, 4, 5, 6, 7. And then that becomes our transformation, so that's C prime. Okay, D would be 7 is our original, 7 -4 was our original. Okay, again, we are subtracting 3 from every X, adding 8 to every Y. So our new point would be at 7 minus 3 is 4. And then -4 plus 8, or 8 minus 4, would be at 4. So D prime is at 4, 4. So starting at the origin, 1, 2, 3, 4. Okay, 1, 2, 3, 4, up 1, 2, 3, 4. And that is D prime. Connect those. All right, the last one. Okay, E prime. E prime is going to be at 4, -6 was our original. Again, -3, add 8. Okay, 4 minus 3 is 1. -6 plus 8 is +2. So this will be at 1, 2. So that means go right 1, up 2. So from the origin, right 1, up 1, 2. And there is E prime. Okay, so here's what you have so far. So these answers were -1, 6, 6, 2, 3, 0, 2, 8, -1, 7, 1, 2, and 4, 4. Okay, move over to the other side. Okay, for essence of time, I'm going to only do the points for these. I'm not going to actually graph them all because I think you guys get the idea. Let's hope. Okay, so let's look at this. So this one says for every x, you're going to add 2, and for every y, you're going to go down 2. So write 2 down 2. So if j prime, here's j, was at negative 4, 7 originally, if I add 2 and subtract 2, negative 4 plus 2 is negative 2. 7 minus 2 is 5. So j prime should have been at negative 2, 5. Sound good? Okay, k prime, the original k was at 0, 8. So 0, 8. Again, each one we are adding 2 to the x value. Oops, I need a little more room on this. And minusing 2 from the y. Okay, so where would k prime be located at? 0 plus 2 is 2. 8 minus 2 is 6. So k prime would have been at 2, 6. Okay. L prime, let's see where L was. L was originally at negative 1, 4. Oops, let's put some space. So if I add 2 to the x, minus 2 from the y, because again, plus 2 minus 2, oh no. L prime would be located at negative 1 plus 2 is 1. 4 minus 2 is 2. So it would have been at 1, 2. Lastly, M prime. M was at negative 5, 3. That's what it says right here. Okay, and so plus 2 for the x, minus 2 for the y. M prime would have been at negative 5 plus 2 is negative 3, and 3 minus 2 is 1. So M would have been negative 3, 1. Okay, if you want to see a picture of what this all looks like, here's one right here. Okay, you can kind of see there's a translation from one to the next. These ones overlap, and that's fine. Okay, they can overlap. It still had the same thing. It still went right to down to. You can see the K's, the J's, the M's, and the L's. They all went down to. All right, let's do the next one. Okay, we're actually going to graph these ones. Okay, these vertices, W is at 1, 7. So that means go over 1, up 1, 2, 3, 4, 5, 6, 7. W, you should be able to graph a little faster at this point, okay, guys? Okay. The next one is X at 6, 5. Right here, so 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5. There's the preimage X. Okay. Y is at 4, 0, so 1, 2, 3, 4, not going anywhere. Okay. Lastly, Z is at negative 1, 2, so negative 1 means goes to the left 1 and then up 2. So over 1, up 2 right here. And that was our Z value. Okay, why did I want to do this one with y'all? So X is easy. For every X, you're going to subtract 7. But what does it say for Y? Y doesn't have a plus. It doesn't have a minus. If it has neither one of those things, you are going to keep your Y value the same. You're not going to add anything. You're not going to subtract anything. So for W prime, it would be like 1 minus 7, and then our Y value is 7, and you don't do plus or minus here. Okay, so Y prime was at 1 minus 7 is negative 6, 7. So negative 6, so I'm going to go over 6 from the origin right here. 1, 2, 3, 4, 5, 6, up 7. 1, 2, 3, 4, 5, 6, 7. You could also start here and just count it over 6, and that will give you the same point because we're not going up or down. So if you want to do these with all of those, you could do that too. So if you want to do this one and count over 1, 2, 3, 4, 5, 6, the next point would be right here. Okay, and you can do that with all of them, but let's do it the correct way. So X prime, X was at 6, 5. So 6 minus 7 is -1. And then it was at 5, so the 5 is going to stay the same because we're not adding or subtracting anything per this y. So -1 up 1, 2, 3, 4, 5. There you go. Okay. And that is x prime. Y prime, again, all we are adding is subtracting 7 from the x value, so 4 minus 7, and keeping your y the same. So 4 minus 7 is -3, 0. So starting at the origin, go over 1, 2, 3, up 0. There's that guy. I might hit the z. Forgot to connect those. And that would be y prime. And lastly, z. Z is at -1, 2. So z prime, oops, I'm going to give myself some more room there. Z prime would be at -1 minus 7, which is -8. And then 2. So -8, starting at the origin, go 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then up 2, 1, 2. There you go. Whew, and we're done with that section. Z prime. All right. I told you it's not going to be that painful. It's probably more painful to listen to me than actually do this. All right, hopefully you have no questions on that. Those points again were -6, 7. Y was -3, 0. Z was -8, 2. And X was -1, 5. Boom. All right. So now we're going to talk about a vector. A vector looks like an array, okay? It's a quantity with both direction and magnitude or size. I feel like I'm watching Despicable Me when the guy's name is Vector. Okay? A quantity with both direction and magnitude or size. Okay, as always, I don't care too much about definitions, okay? They're important, but they're not as important as a lot of other things. All right. A vector is represented in a coordinate plane by an arrow drawn from a point. Okay, it's called the initial point. So you have the point at which the person starts with, okay? And in this case, it's going to be the letter P, okay? And then to the terminal point, Q, okay? The vector is denoted as, again, it looks just like an array. So you have where you start and what direction you're going in. Okay? So what we're going to talk about today is the component form of a vector, and it is written as PQ, again, looks like an array, equals AB. Okay? Where A is the horizontal component and B is the vertical. So A, look at it, it's in the X spot, and B is in the Y spot. Oh, it's not supposed to be a parenthesis, sorry. It's like a little arrow. It's like very intense. Okay. Okay, so how you're gonna do this is you're gonna start at P and you're gonna say how many hops does it go to the left or the right. So let's see that first. Let's zoom in very far. If I wanted to go from P to the terminal point Q, how you know where the terminal point is, guys, is there will be an arrow for the terminal point. So you're starting at P. How many hops on the x-axis does it go till it's in line with Q? Well, it hops 1, 2, 3, 4 to the right. So your A value is written as just 4. And it's not an angle, so I draw this terrible. There you go. Okay? Comma, how many now does it have to go up or down to get to Q? It has to go up 1, 2, 3, 4, 5, 6, 7 hops up. So that's a positive 7 because it's going up. So pretty much it would be the same as our other thing. So like x plus or minus whatever A is, okay? And then y will be plus or minus whatever B is. So just like above, except now instead of H and K, they have A and B. And they write it like this. So instead of saying x plus 4, you're just going to write a 4 here. Instead of saying y plus 7, they just write a 7 here. So let's look at these and write out the one that looks like an array, the vector form, and then what the little like arrow on both sides, parentheses, look like. So where's our initial point? Our initial point would be W, and it terminates at V. So how many hops on the X does it take to get from W to V? To get to W and V, it takes 1, 2, 3, 4, 5, 6, 7, 8, 9 hops, okay? So positive 9 hops, okay? And then is it going up or down? It is going up how many hops? 1, 2, 3. So 3. And that's the vector form. So again, instead of saying take your point and do x plus 9 and y plus 3, they just simplify it by writing it like this. Okay, this vector starts at where? A or B? Where do you see the arrow? The arrow, if it's hard to see in your paper, is right here. So that means we're starting at B and we're terminating at A. So to get to B to A, do we have to go left or right? Hopefully you say we have to go left. How many? 1, 2, 3, 4, 5 hops. So that would be -5. And then how many hops up? 1. And we went up, so it's positive 1. Okay. This one, where do you see an arrow? Pointing at S or pointing at R? Hopefully you can see it's pointing at R right there. Okay, so if you're having a hard time, you can always grab highlighters and highlight the path it's going to take so you can see better how many hops you'll actually need. So how many hops do you need to go to the right or the left? I need to go left 2 to get from S to R. I need to go left 2, so that would be -2, and then how many down? I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because you're not hitting the arrow, you're hitting the dot. So 11 down. Okay. All right. This one, where are we starting? We're starting at B, because here's the arrow. We're going all the way to C. So again, if you want to do your path left and right, then up or down, you can do that. So we're going B and we're terminating at C. So my vector form would be over 1, 2 hops to the right, so that's positive. And then down 1, 2 to hit C, so that'd be -2. All right, what about here? Uh-oh. Here's our line, okay? So we start at M and we go terminate at N. But what happens, I keep drawing these like arrows and I hate that. Or not arrows, like angles. So make sure they kind of look like arrows. What happens on this one? Because do I have to go left or right? No, I just go up. So if you don't go left or right, or you don't go up or down, you will just put a 0 on the left or right. Because I'm not going to the left, I'm not going to the right. All I'm doing is I'm going up 1, 2, 3, 4, 5, 6 hops. So that means don't go left or right, just go up 6. Okay, same idea on this one. I'm starting at H and going to G, but I don't go up or down. So since I don't go up or down, my y value is going to be 0 because I'm not going up the y-axis or down the y-axis. So I'm starting at H, terminating at G. How do I get from H to G? I hop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 hops to the left because I start at H and my arrow is right there, okay? So I'm going towards G. And then since I'm not gonna go up or down, it would be a 0 here. Okay, let's go. flip your stuff over. Oh, mine's all the way up at the top. It's weird. Mine's scanned weird. All right. Next side. All right, let's do the back. So what you're gonna do first is, these are all parentheses. So this is all points. So like S is at -4, 2. So we're gonna graph all those points first, okay? So I said go -4. So starting at the origin right here, I'm gonna go 1, 2, 3, 4, and then up 2. And that's the pre-image S, okay? T is at 5, -1. So that means 1, 2, 3, 4, 5 to the right, and then down 1. Okay, there is pre-image T. Lastly, we have U. U is at -2, -2. So starting at the origin, that means go 2 to the left. So 1, 2, down 1, 2. Okay, and there is our next point, and that is U. Okay, oh, on this one I wrote prime, but it's not supposed to be prime. If I was there, I'm sure you guys would yell at me. All right. So what does it say now to do in vector form? It says -1 and -5. So does that mean to go left or right? That means you're going to take each point and go left 1, okay, and then down 5, okay, if you can't read that. So negatives are left and down, positives are right and up. So each one I'm going to take, and I'm going to go left 1, so left 1, down 5. 1, 2, 3, 4, 5. Okay, and there is, let's do a different color. Let's try to do red this time. Maybe you guys see red. There is S prime. Okay, do the same thing with the next two. Okay, so U, take it left 1, down 5. 1, 2, 3, 4, 5. Okay. So U prime. Last one is T, okay? Take T, go left 1, down 5. 1, 2, 3, 4, 5. Okay, so this is going to be T prime. Okay, if I connect those, okay, what it says over here, it says, notice if I took away all these like yellow lines, so the yellow line, let me try to take away just the yellow and yellow. Okay, and I actually connected these, like I connected S to S prime, so U and T. All of those blue lines are parallel, and now we have a 3D figure. That's what it wants you to notice, that this line, and this line are actually all going to be parallel. So vectors, how they move, are always going to be parallel. Because this would be like going from S, terminate at S prime. Go T, terminate at T prime. Start at U, terminate at U prime. All right, so where were these points located at? S prime was at 4 minus 1 is -5. 2 minus 5 is -3, and that's where that one was. Okay, U right here, -2 minus 1 should have been -3. -2 minus 5 would have been -7, which is right here. So we did that correctly. And lastly, T. T is at 5, -1. So 5 minus 1 is 4. -1 minus 5 is -6. And this should have been at over 4, down 6, which it is right there. So we're good. And this one was T prime. All right, let's hurry up and do the next ones. Okay, this one's a trapezoid. Okay, if you don't know what a trapezoid is, it has 2 parallel lines, 2 non-parallel lines. It's a quadrilateral. It looks like that. Okay, so you have trapezoid A, B, C, D. A is at -3, 6. So 1, 2, 3 to the left, up. 1, 2, 3, 4, 5, 6, right there. Okay, I'm gonna do the purple again. Okay, and that is the original point A. B is at 0, 7. So that means don't go left, don't go right. All you have to do is go up 7. 1, 2, 3, 4, 5, 6, 7. Okay, and that was our letter B. Next, C is at 1, 4. So that goes go over 1, up 1, 2, 3, 4. There's our original C. Last D is at negative 5, 2. So that means start at the origin, go left 1, 2, 3, 4, 5, up 1, 2. Connect those, and there's our trapezoid. Woohoo! 2 parallel lines, 2 non-parallel lines. Okay, what's the transition? Here's the transition right here. It wants you to go 4, negative 1. So what does that mean? That means go right 4, and then down 1 each time. Oop, not an arrow. Or not parenthesis, an arrow. Okay, so let's do that. So right to 4, which one do we want to start with? Let's do C first. So 1, 2, 3, 4, down 1. So C's new point will be right here. I'm going to do it in red. Boom, C prime. Okay, the next one's D. Let's do D next, so let's do that. So again, it's right 4, so 1, 2, 3, 4, down 1. Right here, there is D prime. Connect them. Okay, next one is B. Let's do 1, 2, 3, 4, down 1. There we go, there's B prime. Look at, they're starting to look like this shape, the purple one. Lastly is A, go over 1, 2, 3, 4, down 1. Okay, this one's kind of looking funky, but it's okay. There we go. And there's A prime. Perfect. Look at that. And there's our transformation. And again, if we connected all of these, this line will be parallel to this line, which will be parallel to this line, which will be parallel to this line. And now we have a 3D trapezoid. Okay, these points. Negative 3 plus 4. Okay, 3 plus 4 is 1. 6 minus 1 is 5. Okay, C was at 1, 4, so 1 plus 4 would have been 5. 4 minus 1 is 3. 0 plus 1, oh, sorry, 0 plus 4 for B would be 4. 7 minus 1 would have been 6. Last but not least, D was at negative 5, 2. Negative 5 plus 4 would have been negative 1. And, where are you going? 2 minus 1, or switch. 2 minus 1 is 1. And that's where our points would have been. All those red points. Okay, I'm trying to think if I want to do them all. Because this feels like a lot. Let's do just one more. So on this one, every time, what would you have done? Let's just write what we've done. Positive 3 means right 3. Positive 7 means up 7. So each time. And that one, when it's drawn, would have looked like this guy. Sound good? All right, we will do this last one, this last quadrilateral, because I want you to practice with the zeros, okay? So, what's this say? This says F is at, let's go back to purple. Okay, F is at 0, negative 2, so that means don't go left or right, just go down 2. So there's F. Okay, G is at 3, 3, so that means go right, 1, 2, 3, up, 1, 2, 3, there's G. H is at 5, 1, so that means go right, 1, 2, 3, 4, 5, down 1. Lastly, I is at negative 1, negative 6. Okay. So negative 1, down 1, 2, 3, 4, 5, 6. Now, if you never know how to connect them, it tells you right here. It says start at F. It tells you right here. So it says walk from F to G to H to I, and then there you go. What an ugly shape. It's quadrilateral, but that is ugly. Okay, all the instructions say to do what? Negative 6 means go left 6, and then the 0 means don't do anything. Okay? So no Y, like no up, no down. So all we have to do is take each point and go 1, 2, 3, 4, 5, 6. There's our G. Let's do a different color. G prime. Okay, same thing. 1, 2, 3, 4, 5, 6 lines. This would be H prime. F is right here. So just hop over 1, 2, 3, 4, 5, 6 lines to the left. Okay, there is F prime. And lastly, we have I. It's down here. 1, 2, 3, 4, 5, 6. Okay. And again, how does it tell us to walk? It told us to walk. Start at F. Oh, sorry, that's I prime. So walk to F, G, H, and then I. So connect F and G. Then he walks to H. Then the guy walks to I. And there we go. And you can see all the yellow lines are parallel. Boom. Transformed. These points. Let's do that real fast. Okay, what is 7 plus 6? 7 plus 6 is 6. Or sorry, minus 6, my bad. 0 minus 6 is negative 6. 2 plus 0 is still negative 2. H is at 5, negative 1. So 5 minus 6 is negative 1. Keep the y value, so negative 1. G is at 3, 3. So 3 minus 6 would have been negative 3. Keep the y value because 3 plus 0 is 3. Lastly, I was at negative 1, negative 6. So negative 1 minus 6 was negative 7. Negative 6 plus 0 is just negative 6. And that's where all those red points are located. All right, last thing, then we are done with notes. Woohoo! Okay, and then you'll have plenty of time to work on the worksheet. Okay, I'll pull that up in a minute. So the one says write as coordinate notation, one says write as vertex notation, okay? Oof. So each time you're gonna have an A version and a B version, okay? All you have to do is count one of them. Sound good? So pick whichever one you like the best. I'm gonna start at D. How do I get from here is D prime, here is D. How many over do I go? How many up or down do I go? Well, let's count. 1, 2, 3, 4, 5, 6, 7. So X, would it be plus 7 or minus 7? It should be plus 7, okay? And so in vertex form, it would just be a positive 7. How many up does it take? 1, 2, 3, 4. So Y plus 4, okay? This is the coordinate notation. Vertex notation, to go up 4, it would just be a positive 4. Those are your two answers, okay? So this one, where is the prime number? Where's the non-prime number? Again, this is kind of messy, so maybe you want to do P to P. So I'm going to start regular P, go to prime P, and say, did I have to go left and right, or did I go up and down? So let's see. So we have coordinate notation, vertex notation. So first I've noticed the yellow line goes from here to here is going to the left. How many? 1, 2, 3, 4. So that would be X minus 4. Or in vertex, just a negative 4. Okay, how many, did it go up or down to get to P prime? It had to go up 1, 2. So that would be Y positive 2 because I want to go up 2. And so this one would just be a positive 2. Literally whatever you write here, you put it here. And that's it. Okay, let's talk about the homework. Okay, that was way enough notes. Translation homework. Okay, translation homework is just like the worksheet. Okay, you can follow along. This one says label and graph each figure. Okay, so you're gonna graph STUV, and then it says go up 7, down 9. This one says go left 3, down 4. This one says don't change your X, but every Y goes down 5. This one says go right 4, up 1. Okay. This one says name the vectors. If you can't see, because it's kind of hard, okay. The arrow on this one is on S. Here, let me open it up. So I can just write on it. PDF elements. All right. So this one, the arrow is right here on S. The arrow is right here on F. And then on this one, it's J. Okay. And this is a straight line from K to J. So you're like, K, go towards J. This one is E, go towards F. This one is T, goes towards S. Hopefully that helps. Okay, and then you want it vector in component form. So you just want it like this form for these guys. Again, this should follow very much along with what we did. Okay. This one says, look at the vector form or component form and just do what that says. Same thing here, 8, 3. It's literally just the notes again, guys. Okay, this one says write it in both coordinate form and vector form, just like the notes we did. Okay. It says if K prime was here, and this was the rule you used, where was the original point? So try to think about that one. These are kind of challenge. 14 and 15 should be challenge problems. This one says, if P prime, okay, is image P after translation along the vector, in the vector form this, where was the original point at? So think about how you can solve for those, okay? Then the backside is a maze, okay? Hopefully you guys can see it all. Ah, no, what happened? Oh no, did my iPad just die? Let me see. Okay, so this looks kind of confusing, so I'm gonna show you where to start. So you're gonna start this right here, okay? So let's read what it says. It says, dun, 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 K is at -5, 3, and it's translated using the rules. Add 4 to your X, -7 from your Y value. Where would K prime be? So what's -5 plus 4? Is it -1, -9, or -9? Well, you should know that's going to be -1. And then what's 3 minus 7? Is that -4? Yes. So you color in this guy. Color in this guy. And then your next problem will be this. And you just keep going. So until you hit the end. Once you hit the end, you are done. So not all the boxes will be answered, not all the questions. So again, let's do this one. What is 1 minus 3? That should be -2. So it's either going to be one of these two options. Okay. What is -5 minus 2? -5 minus 2 is -7. So which option is it? It's this option. So we're done with this box, and now we're moving on to this box. And you'll solve for this one. All right. You guys have the rest of the class period to work on this. This will be due, today is Friday. It will be due next Friday, but we're going to be doing these every day. So don't just waste your time and not do this today, because you're going to have the exact same worksheet, exact same notes for everything, like rotations, reflections, all of that. Okay, if you have any questions, write me an email. Have a great day. Bye.